Morning, Haley. I said Haley, not Kaylee. Looks weird. This doesn't look like it's doing what it's supposed to. There we go. Now it is. That's what it's supposed to look like. All right. Ooh, something new today. I mean, we've been doing something new here almost every day, but it doesn't feel like it. All right. Stop at you and look at the board. Reiterating the calendar. You may hear about some changes to state testing. They do not apply to high school students. You only have one test anyway. Just remember your test is going to be 2 weeks from now. On that Tuesday, that Monday, you're going to do practice at home. I'm going to give you 2 days of practice. I will not have an official, every teacher's going to do it slightly different. I am not going to do a video. I am not going to hold a physical class like Zoom on that Monday or that Wednesday. You will have a PSAT practice packet. You may do as much or as little as you feel. If you're that kid that like, well, that means I'm doing 0. Just remember the PSAT test is what determines whether you get into a crummy college, a good college, a medium college. It also determines what kind of scholarships you get. Well, agreed, but if we extend that thought, the PSAT is what helps you do better on the SAT, ACT. Yeah.
Okay, Mr. Cole said you had to sign up for it, but
Had what?
you had to sign up when the office.
No, you sign up if you didn't want to.
Right.
Oh, okay. Good.
It's an opt-out, not opt-in. Yeah, and it's changed like 12 times, it seems like. All right, what's up?
Why is there
I can't hear if you guys are talking.
So there's a PSAT review and then the PSAT. Why is there another day of review if you already have it?
Because 9th graders are taking it on Tuesday, 10th graders are taking it on Wednesday. I'm going to give each class the same packet reviews type thing, so I just don't want to. Agreed, it seems silly. Why would you do a review after? Just remember, anything you can do to review for the SAT is a good thing. So, you know, like I said, I'll let you drive your boat the way you want to drive your boat. Yeah. So the significance is, if, like me, I never took any practice anything. There is a practice for the ACT as well too. I took the ACT when I was in high school. I literally, it was on a Saturday. I distinctly remember this. And so I heard about this test that you had to take to go to college. And I was like, all right, whatever. So I kind of like just woke up and I got in my car. I had to pick up my buddy. I get to my buddy's house, my car breaks down. And then we were like, oh, let's just not take this silly test. And then he was like, no, we'll borrow my dad's car. So we borrowed his dad's car. We drive to the test. I had borrowed a calculator. Why are you talking while I'm talking? I had borrowed a calculator from a friend. I didn't know how to use it, right? I showed up to the test, and they plunked this test in front of me, and I was like, whatever, just a test. And so I kind of gave it a little bit of effort, but not much. And I got a pretty decent score out of it. Why? Because, one, I was good at math. I would have gotten a better score if I had known how to use the calculator, because the test is written knowing that you will have a calculator in your hand for every question. For every question. That means that when they write a thing down, they're not going to put 2 + 3. They're going to put something that you need a calculator to get to the answer, which is why in this school we make a requirement from Algebra 1 onwards, you have to have a graphing calculator. It's the test that you will have on the college entrance exam that gets you into college. Like I said, just because you're a good person, just because you want to, you know, this is like the first thing in your life, other than maybe a driving test, right? Where they literally, there are some standards that actually hold water and consequence to your life. I don't care that you want to know how to drive or you want to drive. If you fail the test, you're not getting a license. You're not driving. I don't care that you want to go to a good college. I don't care that you are a good person. You don't study and get good grades and do well on the ACT, SAT. You're not going to that college. It's that simple. So what's the significance of the PSAT? It's the practice SAT. So, like I said, and there'll be some kids in this class that do it as well. Some kids like literally will go to take an extra class over the summer during the school year. They will go to special tutoring just so they can get a higher score on the test, so they can go to a better school, so they can get a better job, so they can make more money, whatever it is that gives you enjoyment in life, that sort of thing. For the kid that's like, you know what, I've already made my mind, I'm going in the Army, that was kind of me, right? Well, I can only point to my own life of what turned out for me. I didn't think, well, I told you the story. I actually wanted to go to college, but I just didn't have money. So I was going to the Army to get money to go to college. So in my mind, what I thought was, well, I'll take the ACT again, get a better score. Well, it turned out I had a really good score. It just was, I would have gotten a better score if I actually knew how to use a calculator. And I'd actually studied for the test. Kids in this class, like around you right now, to your left and to your right, one of them will buy book. Do I have books over here? They will buy these books. They're big, thick books, and they will spend their sophomore and junior year immersed in these books because it's how you get a better score on the test. And I'm not lying about that. I'm like, in this class right now, there's going to be some kids that do this. I'm not saying it's a bad thing, right? It's a good thing for them. Might not be a good thing for you, but for those that want to get into the best college they can, they want to get scholarships, then they will do those sort of things. So the significance is it's a free, I mean, we said it yesterday, you can pay, it's close to $100-ish to take this test, and Colorado gives you one for free. You take one, you guys got screwed because you get one freshman year, one sophomore. Next year, you're going to take the one for record. And that's the one that you walk around. My AC2 score is right here on my shirt. It's like a tattoo. It goes with me wherever I go.
You're like sophomore visa?
Not your sophomore, but your SAT, like the one you take next year.
You know, when you take next year, then we take a PSAT.
Oh, I keep thinking of your sophomores, your freshmen. 2 years from now, you guys don't get screwed. The sophomores got screwed because they didn't get the PSAT last year. So 3 years from now, when you take the one for record, yeah.
So we do the PSAT this year. Do we do it again next
You
year?
do, but there's two PSATs. There's a PSAT 9 and a PSAT 10. So you're going to take the 9th grade one, and the next year take the 10th grade one, and then junior year take the real one. Yeah. There's no. You'll be fine with taking the PSAT 9, right? The answer is yes, but you have to pay for it yourself. Yeah.
So it includes the math, the English.
It's just math and language arts. We don't give the writing thing. So there is some colleges, I don't know one off the top of my head, but some colleges make you take, there is a writing portion. You guys aren't listening. There's a writing portion of the SAT, and some colleges say you have to take the writing portion as well. I don't know of any one in Colorado that does, but I've heard that there are colleges like that. All right, new stuff. Here we go. While you're copying down the homework, why are you not clicking? That's why. While you are copying down your homework, I will. Technology, you either like it or you don't. There we go. You copy down your homework, I'm passing out the worksheets. Not worksheets, the.
Dang it, I got it.
All right, this is new. It turns out this is based upon if you've been doing well in this chapter. This is pretty simple. Okay. If you have not been doing well in this chapter, then this is incredibly hard. Okay? But if you've been doing well, then this is no big deal. It is new though, you haven't been taught this. And I forgot to tell you, it'd be cool if you had your calculators.
On your paper.
What are we doing today?
We are graphing linear inequalities.
Is it really hard?
I start off by saying, if you've been paying attention, this is pretty simple what we're about to do. If you've not been paying attention, it's like, voodoo, black magic. You won't know what the heck's going on.
What if I still study you?
What?
What's a banshee?
I didn't hear what you said.
What's a banshee?
A banshee is a mythical feature.
I know how to
I
explain.
know it's like the Tasmanian devil.
The
He got
sophomore
called
game.
it. He got called it.
Just means you're spinning around like crazy.
I know what to call it.
Right?
More than spinning, you just
Yeah.
yelling.
I know what it is. A
Yeah,
banshee
me
is
too.
a
I thought she might.
creature that whenever you're about to die,
And then it takes your soul.
Oh, isn't that wonderful?
Yes, go to Banshee.
Who's taking mythology next year?
I'm not gonna be there.
I was going to, but I am taking German.
Well, you can take it again, junior, senior as well too. All right, Mr. Calano. He says that he's got this thing that, well, he teaches Latin, so for me, I wanted him to do a lot on Greek mythology, but he says he does that all the time in Latin, so you want to do more like Japanese mythology and whatnot. So
He specifically told our class not to. Because he doesn't like our class.
And he hates me the most, and I'm doing his class.
no, he doesn't. I already know who he hates the most.
Oh, really?
I play golf with him every Sunday, so I know who he hates.
And
All
you're
right.
gonna tell us.
No.
Yes, you are.
Is it in our class?
Oh yes. Here we go. Here we go. Think about this. I'm making light of this. He doesn't hate any of you. All right.
It's me, for sure.
Here we go. Up here, please. Let's go. All right. So think about this. This chapter dealt with inequalities. The previous chapter dealt with graphing lines, right? We're gonna, in the old saying, chocolate in your peanut butter in your chocolate. I don't know if you ever saw that commercial before. Right. We are going to combine the two chapters into one section. That's today, that's tomorrow, and that's the next day. All right. When we solve equalities, that means you have an equation and you solve it. Look at the board, please. Here's an equation. Hey, it's got an equal sign. Here is an equation that has two variables, suspiciously y and x. Okay. The previous chapter, when we solved this, we didn't technically solve it, we graphed it. But if we think about it, right, is 1, 3. Remember, 1, 3 is a point. Aiden, this is where you should be paying attention. Is 1, 3 a solution to this? Well, if it's a solution, it means it's a point that is on this line. Remember, y equals mx plus b is a line. So what this question is basically saying is 1, 3 on this line, except it doesn't say that. It says, is 1, 3 a solution to this equation? Right?
No.
There's two interpretations. There's the visual interpretation. Does this point lie on this line? And then there's the algebraic interpretation of, does it make this equation true?
Yes.
We're going to do both of those. So let's see. Does 1, 3 make this true? I'll do it algebraically.
Oh, yes.
Yeah.
Well, let's see. This is my x. This is my y. Does 3 equal 1 plus 2?
Yes.
Yeah, so it is a solution. Remember, the only way you can mess this up if you do yx instead of xy. Well, 3 does equal 1. So therefore, that point lies on this line. Okay? Works great for equations. Okay, check. That's the visual interpretation, right? 1, 3 is on this line. Remember, y equals mx plus b. Y-intercept is 2, up 1 over 1, up 1 over 1, up 1 over 1. Okay, great. What would happen in this chapter is we don't deal with equations, we deal with inequalities. Well, we found out that inequalities don't have one answer, they have infinite answers. That's why when we graphed with an open or closed circle. We had arrows pointing towards infinity, either positive infinity or negative infinity. Solutions to inequalities have an infinite number of solutions. Okay? So for instance, is 1, 4 a solution to this one? Remember the previous one was 1, 3. Is 1, 4. We do the same process. We throw this point into this inequality to see if it makes it true or false. Does it make it true or false?
False.
So let's see. Is 4 smaller than 1 plus 2? Well, that's clearly false. So this point, wait a minute, it's not a line anymore. It's an inequality. So we got an issue here with our visual interpretation, not our algebraic interpretation. That's pretty simple. Is 1, 4, does it make it true or false? Easy to do. But the visual interpretation needs a new definition. This isn't a line. If it says y equals x plus 2, it's a line. But y less than x plus 2, it's a different shape. That's what today's class is about. What's the shape? Squiggle is when 2 dimensions. Remember, one dimension, one number line. This is 2 dimensions. We got a y and an x. We're going to find out. We're going to find out. Okay. So solutions to inequalities, the first thing they will have you do tonight for homework is they will just give you a possibility and they will say, does this make this true or false? It's a yes or no answer. The only way you screw this up is if you mess up the order. Remember, the order of a point goes x comma y. So we put an x and a y. We plug those numbers in. We see if it makes it true or false. Is 2 smaller than 1 plus 2?
Yeah.
Yes.
Sorry.
2 is smaller than 3.
2 is smaller than 3. Therefore, that point is a solution to that inequality. Question.
First thing on the homework is graphing.
I know. I'll get there. We got to get there first. Okay. So is that a solution to this? The answer is yes, it is. Great. See that one more time. Don't be afraid of fractions. It's not that big of a deal. Is -5, 4 a solution? We throw those two values into our inequality and see if it works. Remember, this is your x. This is your y. When we toss that in, -5 divided by 5. -5 divided by 5 plus 2 is -4 smaller than 1?
Yes.
Okay. Hey, Rowan, move. Just somewhere where Aiden is not distracted, because you won't.
I was gonna talk to you.
I know, but I'm saying if you move, Aiden, there's a chance he might pay attention.
I am paying attention. It's even hard. I already did that. Box 1.
No, you didn't. I haven't showed you how to do box 1.
It's not that hard. It's just, it's yes
All right.
in the first one, and then it's no in the second one.
It's no in the second one?
Yeah.
Hmm.
It's not the answer to the question. Hold on.
Talk me through number 1, Aiden.
So, basically, so you said, is it like the line on it?
Remember I said that's true for equations, not true for inequalities. Inequalities are not lines. That's what this section's about, is what's the shape. We'll get there, just we do this first. Keep talking.
So 3 is yes for 2 over 3.
Why are you saying yes?
Because it, like, I don't know, basically goes into it. Like,
What do we got to do with these numbers?
I think it might be true.
make them go up into there.
Okay, but
Is
what
it
order do
true
they
or false
go in?
answer, or
What order do they go in?
go 3 with the 2 over 3, and then 6 with the 4 over
Okay, I agree with that.
Uh-huh.
3 divided by 3 is 1. 1 times 2 is 2. 2 plus 4 is 6. Is 6 less than or equal to 6?
Less than. Or
6 is not
equal-
less than
or
6,
equal to.
but it is equal to, so that one is 100% is yes. Good job.
Yes.
Okay.
And then the next one.
Second one, careful with the negatives. They're both negative, so it's not, but you could forget if you're multiplying. Okay? Agreed, but be careful with the multiplication, right? So -3 times -1 is 3. 3 minus 2 is 1. Is -1 bigger than 1? No. Yes. I'm plugging in a 3 for x, yes? 2 times 3 divided by 3 plus 4. We good? Yeah.
So for the answer, is the answer yes?
It's a yes or no. It's either a solution or it's not a solution. You can put y in if you wanted to. We came with this basic idea of really what we're doing is evaluating an inequality, seeing if it makes it true or false. The big question is, what's the shape of this thing? We know that if that was an equal sign, it would make a line. It doesn't make a line when it's a greater than or less than symbol. That's what we're about to find out. Okay, graph a linear inequality. This is, I don't know, I find this kind of fun. All right, graph a linear inequality. Equation, yes? How do we graph it? What do we do?
You start with y, or
We start with the, remember the words? We start with the y-intercept. We put a dot on 1, right? And we apply the slope to it. So that's what we do for equations. And what do we do for that one? Okay. The ordered pairs that make this true form a line. Any point on that line are solutions to that equation. We've got a problem with this one because there's infinite number of answers. Right? problem with that. 1, 3 works for there, but a whole bunch of numbers that start with 1 will work for this one as well. There's only one number, if I make x1, that works, 3. If I throw 1 in for x, there's an infinite number of answers. In fact, any number that's smaller than 2 works for y. Infinite. That's a problem. Those make lines. These don't make lines. So let's see what it makes. 1, 3 works. 1, 4 works. Whole bunch of numbers work. Okay. All right. This is the easiest way I can explain the shape. All right. So look at the board. So equation or inequality?
Equation.
Let's graph that sucker. All right. If I graph that sucker, well, there's a point that makes it true, right? If I graph that point, there's 2, 3. I can continue that process a while, but easiest way to do it is to graph the y-intercept 1 and apply the slope. So apply the slope, right? A whole bunch of times we get that line. I'm going up 1 over 1. Yes.
Where'd you get 2 from?
I just threw a 2 in because I wanted to use a 2. Right. I could have chose a 20 if I wanted to. Right. I get a line. Cool. There's my line. That's the equation. Inequality, all I'm going to do is take that equal sign and make it inequality. Anyone I want. Greater than, less than, greater than or equal to, less than or equal to. Okay. Well, let's see what would make this true. Does 2, 3 make this true?
No.
2 plus 1 is 3. 3 is not less than 3. So 2, 3 didn't work. Okay. However, if I throw 2 in for x, this would say y has to be smaller than 2 plus 1. So if I start right here at 2, the answer has to be smaller than, so where are the numbers that are smaller than 3 from my finger? Straight down. Straight down. So all the answers that make that true, 2, 3 didn't make it true. So this point right here didn't make it true, but all the numbers below it did. In other words, all the values that are smaller than 3, right there, that red line right there. By the way, I can repeat this process not once, not twice, but an infinite amount of times. Hey, 3, 4 made this true. 3, 4 doesn't make this one true. However, any number smaller than 4, when I plug in a 3, makes it true. So from here straight down makes it true. So for instance, 4, 0 would make it true. Okay. It turns out that the shape it makes is, take a guess.
Hairbrush.
I can see that. It turns out that the solutions that make it true is the area, we say the region, that is below this line. Well, what's this line? X plus 1 is this black line. So what's the region that's below it? Well, it's this, it's that right there. That's the shape. We don't give it a name. We call it a region. Okay. It's called the area that's underneath the line that's defined by this, x plus 1, x plus 1. Don't remember if we do it in pre-algebra or not. I don't think we do. Okay. All right. So those are solutions to linear inequalities. There's one small thing I got to add to that. That's the basic idea. If you remember how to graph a line, hey, you remember how to graph y equals mx plus b? Then all you have to do is find out whether the area is above or below the line. It's going to be one of the two. It's either going to be above the line or it's going to be below the line, and there's an easy way to figure out where it lies. Okay? So solutions to linear inequalities are regions, right? They're regions of the graph. Oh, by the way, your calculator will do this. I'll show you here in a second. Okay? We shade that region to indicate where it lies. Remember when we solved a simple inequality, y is greater than 4? We did a wiggle, 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 right? Pointing to the right. This time it's going to be a region of the graph. It's still the same thing. You're going to do some shading. Okay. The shaded region represents where all the answers to the linear inequality live. In other words, any point in that shaded region, let me go back, any point in this region makes this true. So for instance, I can pick any point at random. I lost my pen. Any point at random in the, here, look, I'm picking 0, 0. 0, 0 lives in this red area. Do you see it? If it's in the red area, that point will make this true. Check it out. 0, 0. What's 0 plus 1? 0 is smaller than 1. Any region that's not in the red area, finish the sentence, won't make that true. So pick a point up here.
55.
55, well, I don't know. 55, I think will be in the red. Pick something over here.
Positive 10.
-5,
Positive 10.
+5 would be in that area, right? -5, +5 would be right here, right? That's 6. So that's supposed to make it false. Let's see. Put -5 here. Put a 5 here. What's -5 plus 1? 5 is not smaller than -4. The white area represents where the solutions don't live. The red area represents where they do live. How do we find the red area? That's what the rest of the class is on. And it's not as hard as it looks. Okay. We okay with the concept? Red area is true. White area is false. All right. We call them regions. So here are the steps. Was I nice to you and printed out the steps for you? They're already there. Okay.
How did you get Y by itself?
Y by itself will be the hardest process. Like if Y is not by itself, that's the only challenge, and it's not that challenging, but it could lead to some challenge. All right, now's where you're paying attention, girls. Okay, let's do a couple of these. All right, watch me do them one at a time. Step number 1 says to get Y by itself. Is Y by itself?
Yes.
All right, lucky for us. Merry Christmas, nothing to do there. Step number 2, I'm going to graph this sucker like I would a normal equation. In other words, I'm going to pretend that that says equals and just graph it as I normally would. So if that said y equals x plus 2, I'm going to graph that. Where's the y-intercept?
It's up and down.
Where is the y-intercept?
0.
1.
Recall that the y-intercept is the
Oh,
m or the b.
The B.
The b is the y-intercept. Where's my y-intercept? 2. So I put a big honking dot on the y value 2. See what I did? What's the slope of the line?
1/1.
Yeah, that's what I meant.
Everybody see it? It's a 1. And we write slope as rise over run, so the slope is 1.
Makes a stair.
Okay? So that means from this point I go up 1 over 1. So I go up 1 over 1. I go up 1 over 1. If I want to go in the other direction, it would be down 1 over 1. Okay? Here comes the new rule. It's step number 3. Okay? Do you remember when we graphed linear equations, we put an open or a closed circle? What did the open circle mean? It's the solution or it's not the solution? It's not the solution. We have the same thing, except it's how we draw our line. I don't play connect the dots. I put a special line. One represents an open circle. One represents the closed circle. It's the same idea. So here's the idea. Okay, if you have this is called strictly less than or strictly greater, meaning no line underneath of it, we put a dashed or a dotted line. If it's this, we put a solid line. That means it's included in the answers. So I'm going to put a solid or a dashed line. Dashed line. Why? Because there's no line underneath of it. What it really means is all the points on the dotted line don't work. So for instance, all these red dots do not work. Hey, here's one, 0, 2. 0, 2 will make this false. If I put in 0 for that, 2 is not smaller than 2. If it's a solid line, like if it was this, and I threw that in there, it would make it true. 2 is less than or equal to 2. Okay? Solid line if there's a line underneath of it. Dashed line if there's not one. Easy. Okay. Solutions to linear inequalities are regions. There's only 2 regions here. By paying attention, either above the line or below the line. It's one of the 2. Okay, here's where you got to pay attention. So which one is it?
It's the dotted.
It's either above or below the line.
It's below.
Here's how you do it. The easiest way is just to pick any point in the region. Any point. What's the easiest point to always pick? We're going to pick 0, 0. If 0, 0 makes this true, you found the region. If 0, 0 makes it false, then it's got to be the other region. If 0, 0 makes it true, you found the region. The region is either above the line or below the line. It's one of the 2. If 0, 0 makes it true, That's the region you shade. If 0, 0 makes it false, you shade the other region. Okay? This is called picking a test point. We're going to pick somewhere that isn't on this line. That's the only thing stipulation you got to do. You can't pick something on the line. Anna, you awake? Okay? So we're going to pick the easiest point up there. The easiest points are 0, 0, 1, 1, 2, 2, 3, 3, right?
I want to do 10.
You can pick 10, 10. It'll work. Where is 10, 10, by the way? Is it below the line or above the line? What? I think it's probably below the line. That 10, 10, I believe, is right here. Okay. So we're going to pick the easier point, 0, 0. So I'm going to pick 0, 0. I don't always pick 0, 0. If the line goes through 0, 0, I can't pick it.
1, -1.
You want to know why I would not pick that one?
Why?
Because I will screw up which one was negative, right? Because remember, when you throw them in, you got to put the X on the X and the Y on the Y, and it's flip-flop. You pick 1, 1 or 0, 0, it doesn't matter if you screw it up. It's still 1 or it's still 0, okay? 0, 0 is easy too because it makes the math really easy. If I plug in 0, 0, I get 0 is less than 0 plus 2. What's 0 plus 2?
2.
Is 0 smaller than 2?
Yes.
So you found, there's the test point, you just found that it makes it true. The side that is true is the side you shade. Did we find 0, 0 made it true or false? So we shade that side. We shade the side that 0, 0 was on. If 0 had made it false, we would shade the other side. And that's the whole process right there. Literally, that's the whole class right there. Okay? No, we got to do a bunch of examples here, but I'm saying it's no more complicated than that. It looks complicated. It ends up being, it's just a combination of the last chapter and this chapter. All right, let's do one. By the way, what does the shading look like? It looks like a big hot mess. Okay? Just put some wiggles to indicate. Some people take colored pencils and they'll spend time. Okay, have fun. The rest of us are just going to put a couple indications. I mean, I literally, when I do this, I go this. Done.
That's what I just did.
All right. Okay, let's do one. Box number, what, 2?
3.
3? No, it's 2.
3.
No, it's 2.
3.
We're on box 2.
We do the one with the fraction.
We'll do that. Remember, the fraction is nice because it's the slope. It's no big deal. All right, box 2. Here we go.
Why is there a fraction?
Step number 1, get y by itself. Merry Christmas. Y is by itself. Eventually, we will get to some that do not have y by itself. Stop me if you get lost in any one of these steps. Porter, you with me? Okay. Y is by itself. Let's graph this sucker. Remember, be thinking y equals mx, I didn't write x, plus b. Kaylee, what's the b here?
Why?
What's the b here?
There's no.
So therefore b is?
0.
B is 0. Because I could always put plus 0, right? So b is 0. So put a big honking dot on 0, and oh, by the way, now we can't pick 0, 0 as a test point. Yuck. What's the slope here? What's the slope? And Kylie said -2/1. Because she's thinking ahead that she needs to apply the slope. So here's your y-intercept. So we're going to go down to right 1. Down to right 1, put a dot. Do it again. Down to right 1. We go in the other direction, it would be what? Opposite of this. Up to left 1. So from here, up to left 1. How many dots do you need technically? 2. Technically, you just need 2.
So we should go
I always put 4 because, I don't know, I'm a math teacher. It's what we do. Solid or dotted line?
dotted.
Dotted? Okay. So put a dotted line, and then you're going to stop me for those who are like, I have no idea why we put a dotted line. Are we okay on why we're putting a dotted line?
Dotted line.
Remember, a dotted line means that anything on the dotted line does not make this true. Solid line means, yeah, anything on that line makes it true. I can't pick 0, 0. It's on the line.
1,
1.
4, 4 is very nice. So is better.
1, 1.
1, 1. Smaller is always better, right? In this case. Okay? We're talking about apple pie, and no, I went larger. So I'm going to pick a test point. My test point could be anything. It has to be either in this side or this side.
1-1.
1-1 is your really good choice, right? 2-2, 4-4. I mean, -1 is an okay choice as well too, but there's negatives involved. We want to mess with
-4.
negatives.
-4.
But if you get the choice, always pick the same number. Okay. All right. I'm going to pick 1-1. Right. There's 1-1. It's the easiest number. We're going to throw. Let me erase all this. We're going to throw 1-1 and see if it makes it true or false. If it makes it true, that's the side you shade. If it makes it false, we shade the other side. Point. You can't choose a test point that lives on the line. Yes.
What do you do when it's like actually smaller than -1?
What?
What do you do when actually smaller than
That's a vertical line. Okay, so here we go. 1-1. Plug in 1 for each one. Is 1 smaller than -2? Is 1 smaller than -2?
I mean, yes.
Here was 1-1. Is 1 smaller than -2?
No.
So you just found the false side. You need to actually shade.
The other side.
You got to stop me if you're lost.
Just like.
What? You get to pick for your test point either side. Then you throw that point. This is what I chose. I chose right smack here. I throw it in there. If it makes it true, you shade that side. If it makes it false, you shade the other side. Anybody else? That's usually the question everybody asks right there. Great, I got an answer. Well, how do I know which side to shade? I usually get some smarty pants out there that say, hey, look, Mr. C, I can look at the inequality and tell you which side to shade. It says y is smaller. Well, you can kind of maybe visually see that the smaller numbers live. Okay, be careful with that. When the line looks like this, it's easy. Less thing goes there, greater thing goes up here. When it's kind of more vertical, be careful. But I usually get some kid that says, oh, I can do this without doing that test point.
Mr. C.
When you shade the other side of your test point. Yes, Haley.
So for this, you just take a point on one of the sides, not on the line, but on one of the sides, and you put it into the X and Y points. If it doesn't make it true, you shade the other side.
Perfect. Well said. By the way, it doesn't get any more complicated than this. Even the ones that you think are complicated. Which one did you want me to do? Because you thought it was complicated? Which one is that? Number 4?
Number 5.
Number 5? All right, let's do number 5. We'll come back to this one if we need to. By the way, why is this one solid?
But it's solid.
Because it has a
Because there's a line underneath of it. All right, let's do a supposedly hard one. All right, here we go. Why do you think this is hard? Because you see fraction, you think of, remember, we're graphing it. Okay, next one might be hard. Okay, here we go. What's the y-intercept?
The next.
Y-intercept is,
3.
put a big fat dot on 3. Whoops, sorry.
That one, yeah.
It's just as easy. What's the slope?
3/1.
All the way around.
-3/1.
No.
1/3 negative.
So up 1 over 3. How many points do we actually have to graph?
2.
Technically, that's it. Now, he's saying all of them because eventually we're going to draw the line. That is all.
That's infinity, though. I don't want that infinity time.
If you're like me, you put at least, I don't know, 3 dots one way. Solid or dashed?
All of them.
Haley, where's my test point? What do you want to pick?
70.
She wants to pick 1-1. It's a perfectly fine choice. I probably pick 0-0. It makes the math even easier.
Origin point.
You can, as long as the line doesn't go through 0-0. We like 0-0 because when 1/3 times 0 is,
0.
there's no math with a fraction involved in it. So if I pick 0-0, I get 0 is greater than, well, that goes away, 3. Is that true or false?
Yay or nay?
Is 0 greater than 3?
No.
It's
So here's 0-0. Which side am I going to shade?
0. It's opposite.
There you
That's
go.
not good enough. You brought the little corner of it.
That's literally all I'll do.
Corner.
Yeah, you missed a spot.
I missed a lot of spots.
You can just go like really big. You'll get all of it.
Guaranteed there's somebody There's somebody that will shade the whole thing really carefully.
I just go.
No, she's doing it right now as I was talking.
Wait, really, Michael? Let me see your paper. Why? Why would you?
I don't know. Some people are artists. They like doing that sort of stuff, right? Drive on with your bad self. That's cool. All right. Do you think this one's hard?
No. We can skip it.
Do you want to do it?
No.
All right, we'll do this one. This one's only challenging because where do we put this negative?
Negative. On the top. Or the bottom.
Or the bottom. Either one, it's your choice. Okay. What's the y-intercept here? Y-intercept, Nathan, is? Big honking dot on -2. What do we agree on? Where we put the negative, top or bottom?
The bottom.
There is no right or wrong answer. You can put on either one.
Wait, his was wrong.
That's the slope. So I'm going to go down to right 5. 1, 2, 3, 4, 5. Technically, 2 points is all you need. I'll do 3. If you do it the other way, that would be put the negative on the bottom.
Go.
So up to left, 1, 2, 3, 4, 5. Solid or dashed?
Solid.
Solid. So solid line. Okay. What's our test point?
0, 0.
Heck yeah. I'm picking 0, 0.
Equals -2.
The cool thing is that here's the magic of the 0, 0. This thing just goes away. Because if it's a solid line, it means any point on the solid line will make this true. So for instance, 0, -2 will make this true. Okay. If it's dashed, it means nothing on the line makes it true.
Why don't we just go with solid? What's the point? I'm just gonna go.
Oh, because you're leaving off a whole infinite number of points that could make it true. Okay? Or make it false if it's dashed.
But why are we doing that too?
Well, remember, we want to put the entire region that makes it true. So that's why it has to be solid or dashed, because that also defines more points that either make it true or make it false.
That's a lot of coloring.
That's a lot of stuff. All right. Is 0 smaller than -2? Is 0 smaller than -2?
No.
Is 0 smaller than -2? So here's 0. What side are we shading? That side. Nothing hard today. It just combines what we learned last chapter and what we did this chapter slightly. We're going to do 2 days of this right here. Some of you probably got it right now. You got it well, but there's some couple nuances we'll talk about tomorrow. But for the most part, one thing I also want to talk about are reminding you about vertical and horizontal lines. All right, who remembers? All vertical lines are of the form
K something.
something with a K.
X equals K.
X equals K. That's a vertical line. All horizontal lines are of the form.
Y equals K.
Make sure you keep that in your head. So you're going to get the same thing. You're going to get, instead of it being equals, now you're just going to get less than, greater than, that sort of thing. It's still vertical or horizontal line.
Doesn't matter if it's K.
Doesn't. K is just, there's a lot of German words in math, and K is constant in German. That's how you spell the word constant. So vertical or horizontal?
What's the difference again? Wait, vertical.
You just wrote it down. That's a horizontal line. So where do I put the dot?
On the 3.
I put the dot on the y value 3, and I draw a horizontal line with what? Solid or dashed?
Dash.
So,
And now, just by looking at it, guess which side we're going to shade. Look at the inequality. Above or below?
Below. Above. I mean, sorry.
You see it says y is, the answers are bigger than 3. Well, I don't even need to do a test point for that. I know where the numbers that are bigger than 3, they're up there. If you were to pick a test point like 0, 0 is not bigger than 3, that makes it false. Okay. When you pick a test point for your vertical or horizontal lines, you only get either 1x or 1y. Just plug in one number. All right, you feeling confident?
Yes.
All right, I want to show you one last thing. Pick one, any one of the boxes, other than this one.
7.
7?
we already did that.
9.
There is no 7.
Yeah, we did 7.
All right, let's look at
Did you just say there is?
this one. Grab your calculators.
Number 9.
Grab your calculators. We're going to do number 3 on our calculator. Hey, stop what you're doing. Grab your calculators. All right. You have to turn on, this is brand new. You got to turn on an app. Okay. The app button is where my finger is. You see it?
What does it say? Oh,
It says app, literally.
apps.
You're going to press the app button and you're going to scroll down to where it says Inequalities. Mine's number 7. I don't know if yours is. Listen, please. Scroll down to where it says Inequalities, hit enter. It should say something, it might say something if somebody already turned it on for you. If they haven't, then you absolutely notice nothing has happened. It looks like nothing's happened. Turns out something has happened. Okay? Cool. Press any key. So you've turned on the inequality. It will now graph inequalities. What? Apps, inequality video. Apps.
Wait, where is it?
It says apps.
Oh, there.
I couldn't see. I don't know what the heck was going on. Okay. Now, what the program called Inequalities allows you to do is, listen up, please. Instead of there being an equal sign, we can now change it to a greater than, less than, or a shade. Okay. So, for those of you with the big expensive one, right? Highlight the equal sign. Highlight the equal sign. Did I just turn my apps off? I think I did. Continue. Who's got this one? Am I the only one? Okay, then I want to explain this one. All right. So if you notice when you turn on your inequalities, down at the bottom now you have your inequality symbols.
How do we get to them?
Okay. So how do you get to them are the keys that are right here. Don't press anything yet, but if you press one of these keys that's directly below the less than, greater than, equal to, you get that symbol. So I want to have a greater than or equal to symbol. That is my button right here. So you're going to press that button. And notice that you now are going to have. One second. There we go. I'm sorry, you got to press the alpha button and then the inequality button. So you're going to press the alpha button and then that button below it. Now you have a greater than or equal to, or less than. All right, so we want to get that symbol. The symbol's right here, right? So we're going to press alpha and then
And it shows you what side you're going to stay in.
and well, that's a different way of doing it. All right. No, we want that. All right. So once you have that done, now we all have a greater than or equal to symbol. So we're going to hit alpha and that button.
Mr. Chartier.
See it? Okay. Now scroll over. Now type in that 3x minus 1.
And if theirs aren't working, it's border. I don't even have
Who? We don't have. Do you have a CI-83?
Mr. Chartier.
So we're going to hit apps.
I actually carry something.
All right. Scroll over now. Type in 3x minus 1. Yes, but I was trying to keep everybody in the same.
It didn't go.
What about this?
Okay, everybody there? And then when you hit the magic graph button, you will get a graph that looks like what you just drew.
Mr. Chartier.
Did it work? By the way, you turn on that app. It's always on now until you turn it off. So to get those less than, you can leave them down there. It's fine. Did it work? Did you grab it? Haley, did it work? Haley, did it work? Well, we know that. You got on the equalities?
Mr. Chartier.
Ooh, wait for you.
It's not important. But so it'll look like this. When you, all right, Haley Miller, any questions?
Yes. What buttons were you clicking on the calculator to get the inequality?
This is really hard to do on a Zoom unless you're looking at my calculator. So I'm going to turn my camera on. See ya. Stop share. Start the video. All right. See the calculator?
Yes.
All right. So you're going to hit the apps button right here.
Okay, and it pulls you up to the screen.
Okay.
Something.
Right.
Right.
Well, the first thing you're going to do is hit the app button, APP, app, where my finger is.
And then go down to,
Okay. Once you
the
hit
apps
that, you're going
button.
to scroll down to where it says Inequalities. Should be like number 7.
Mhm.
Hit enter. I've already got mine turned on, so I get that message. If you've already turned it on, you'll get that message as well too.
Yeah,
Okay,
I
good.
got that message too.
So now we're on the. Show me your screen again. I just got to see which calculator you got. Oh, you got mine. Okay, cool. So what you're going to do
Yeah.
is you're going to use your cursor buttons. This one's a little bit different. You're going to scroll to where you get a box around that part right there. You see that? You're going to scroll left until you get a box, a blinking box. You see
Okay.
that? Now hit enter.
Yes.
And you see it gives you an option of you can change the color. The second option down, if you highlight it and or if you move left and right arrows, you're going to see all the inequalities pop up. Less than, greater than, less than or equal to,
Okay.
greater than. Pick whichever
Yeah, I
one
see
you
that now.
want. Okay, we wanted a greater than or equal to. So once you have greater than equal selected, hit enter, and then enter again for OK. And now you can see that on your line there, it'll say Y1, and it should say greater than or equal to. Yes.
Yes.
Now type in 3x minus 1. And then hit graph, and you're going to get a nice, cool
You
graph.
should give. Yeah, and then it'll give you like either the dotted line or the
Like this.
Yes.
There you go. You
Yeah,
did it.
that's what I got.
Cool. That's how it's
Cool.
done. Now, what'll happen is you
Thank you,
forgot
Mr.
that it's
C.
on greater than or equal to, and then you'll have to remember how to change it back to an equal symbol. But we'll talk about that another day.
Yeah.
Okay. Any other questions?
Not that I have right now.
All right. Cool. I'll see you tomorrow.
Thank you. Yep.
See ya.